Okay, good afternoon. Alright, so I will record this video to go through the term checkpoint, okay, and then try to highlight some of the common mistakes lah, okay, that you guys have committed. So I think not too bad for a first attempt at the pure chemistry test lah. So you can see some of the questions is very application based, require you to code data, and some of the things maybe not as simple as you think it is lah. Okay, but I guess it's a good exposure for you lah. As we build up to the end of year. Okay, so whatever it is, I think take it positively. Assure yourself that you are on a continuous learning process. Alright, okay, and then do take note lah of some of the mistakes that you make in terms of the answering techniques lah. Okay, I think end of the day content most of you will be okay lah. Yeah, but it's about how you handle the different sort of questions lah. Okay, and how you pay attention to the question descriptors. Right? Okay, right, I shall start now. Okay, so for the first one is a question on diffusion. So in experiment A, the following apparatus is set up to investigate movement of hydrogen sulfide. Okay, hydrogen sulfide is this H2S and then sulfur dioxide SO2. Okay, so you are required to label the position for the first one. Okay, so this one is over here lah. Alright, the X is over here. Alright, okay. Closer to SO2. Reason very related to the second part. Okay, so we need to calculate the relative molecular mass. But make sure you spell out the whole thing when you explain in part 2. Okay, when I write, I can write this way lah. Okay, but don't use short form. Some of you use short form. Okay, for the second part okay, cannot actually. Okay, so I think one thing that when you check your periodic table you got to be know what numbers to actually pick it up because some of y'all when you calculate H2S land up is like this. Wait, end up you all do something like this, then become 18. No wrong alright. The MR, you're supposed to look at the mass number and then add it up. Okay, 2 times 1 plus 32. So that is 34 for H2S. Yeah, then some of your SO2 become 32. Okay, so the MR for this case is oxygen is this way lah. If you refer to your periodic table all on here lah. Let's go and see Okay, this one, and this one. Okay, so go for all these to find your relative molecular mass, the mass number or what you call the relative atomic mass over here. Okay, let me go back to this. So the MR is 32 plus 2 times 16. So that gives you 64. Okay, so which means this one is the one that actually diffuse faster. Okay, let's look at part 2 okay, to explain why it diffuse faster. Okay, so you are required, I think very clear the question say using relative molecular mass. So you must actually list down or code the relative molecular mass. Okay, so you must list or code so I'm looking out for the figure, okay, which is 34 for H2S or 64 for SO2. Must compare the relative molecular mass. Okay, if you never compare, no marks. Alright, okay, then explain your answer. That's explain means you relate to theory Okay, so what's the theory here? Okay, so you must compare the rate of diffusion. Okay, the rate of diffusion so you don't say what travel faster or these kind of things sometimes I'll use this term travel rather than diffuse. No, the concept here is diffusion. So you must say the H2S will diffuse faster than the SO2 so as a result travel a longer distance. Okay, you use travel for the distance, okay, but the movement itself you use diffusion. Okay, rate of diffusion the concept here is rate of diffusion is higher if the relative molecular mass is lower. I can use short form, you cannot use short form, okay? So I use MR, okay? But when you explain, write out the full thing, relative molecular mass, okay? And then list out the figures, okay? That one is important, must list. Okay, some of y'all never list, then unfortunately no marks for you lah. Or some of y'all actually calculate wrongly. So yeah, that is something that you must take note of lah moving forward. Okay, yeah. Okay, so let's go to the part 3, okay, that we have over here. Okay, part 3. Okay, so this one I think very similar to the ones inside your notes. I have went through with you all. Okay, so the experiment is repeated at a higher temperature. I think the concept here, most of you are aware. When you increase the temperature, you actually increase the rate of diffusion. Okay, but the question is actually asking not so much for the explanation, but the similarity and difference between the observations. Observation means what? Means something that you can see lah, you can hear, you can feel. Okay, your 5 senses basically. Alright, see, hear, feel. Seldom taste lah. Okay, see, hear, feel. Smell also sometimes. Alright, okay, but this case we focus more on the seeing part. Alright. Suddenly lost for my 5th sense. Okay, so similarity here is this, is your yellow powder will form at same distance. Okay, so the key thing here is really same distance. Okay, I think a lot of you are not able to hit this point. Okay, some of you will say form closer, okay, to SO2. Okay, sort of like correct. Okay, but actually I'm looking out for something more specific. Form closer means what do you mean? Like 20 cm, 10 cm, or 5 cm away. Okay, that's a bit vague over here in a sense. So you to hit really the point here is you must say it will be at the same distance, okay, to the so you see the way I say is very specific, to the left of the cotton wool soaked in concentrated SO2. Yeah, so a lot of you all actually just say closer lah, without really saying at the same distance to the left of the cotton wool, okay, as experiment A. Difference here, I think a couple of y'all can actually hit the difference, as in say it takes a shorter time or it's faster to form. Okay, if you say faster also, I accept it lah. Alright, because you can time it on this one can see. Alright, so important lah, okay, to mention this. It will form in a shorter time or it will form faster. Yeah. Okay, then let's take a look at the part 3. No, sorry, I mean B part 1. Okay, so for B part 1, I think some of your struggles here is talking about the spacing lah. Yeah, some of you just say move faster in all direction randomly, then causes the gas to expand. Just say cause the gas to expand. Okay, so they want you to, the question, what does it says? Okay, it says use KPT, kinetic particle theory, to explain how come volume increase. So inside here is at 20 degrees Celsius initially, then placed in a hot water that's 50 degrees Celsius. Then you see the volume increase. Okay, so this one you must talk about the spacing between the molecules. Okay, the spacing between the molecules. So they you move further away or become more spaced out. Alright, okay, I think most of you can point the first point lah, have move faster or more KE. That one I think, okay, some miss out the energy lah. You must tell me is KE okay. I noticed there are instances some miss out the energy. Yeah. Just let me do a quick scan yeah, must point out which sort of energy for me lah. Right, okay, can. Alright, so the second question over here. Okay, so this first part I think quite okay lah, except maybe just one who write fractional lah. Okay, you can see there's no fractionating column so fractional not accepted. And if you write just distillation is also not accepted lah. Alright, important to tell me is simple distillation. Okay, simple distillation. Don't just write distillation, that one wrong. Okay, then next thing, okay, at the end of the experiment, on the diagram, use arrows, label the position of liquid Z and water at the end of the experiment. Okay, so important when you draw the arrow, go all the way in to point at what's inside the flask and what's inside this tube. Some of y'all, the arrow never reach one. Some of you will just point. Actually, I don't really like that. Okay, point into it. Alright, be specific. Some of you a lot of spacing between your arrow. Some, I don't want to accept one, right? Like water like that. Wow, I want to penalize y'all and cannot draw properly. Yeah, some of y'all really draw also got so much. The arrow only also don't want to go and point properly. Okay, so make sure you join in some like that. Just point water like that. Okay, make sure the arrow go inside lah. Aiyo. Why so stingy your arrow? Okay, next one. Okay, next one is what is the purpose of the beaker of cold water? It sort of acts like your condenser. Okay, a lot of y'all I think can point out it condense. Okay, but I'm looking out for one more thing. Okay, how does it condense? Okay, so you need to point out to me what allows the condensation of the water vapor. Okay, which is the first part of the answer. So I didn't accept if you all didn't mention about provide a cold surface. Yeah, so I'm looking out for something that is more specific. A lot of them are missing on this cold surface. Yeah. Okay, then but part D then okay, it's quite simple. Most of y'all can say smooth boiling, prevent bumping, those kind of things. Okay, this one I don't think there is much issue generally. Yeah. Okay. Then we come to part E. Part E, some of y'all write condenser. I didn't accept because the cold water is already there to condense the vapor. So the cold water already provides the cold surface. Okay, this one not accepted because it already provides the cold surface. Then another thing is, okay, y'all wrote about thermometer. Okay, depending, this one I accept some, I didn't accept some. Okay, I accept for those who tell me okay, mention about where to put the thermometer. Okay, at the top of the round bottom flask. They say at something like this. So I just say put thermometer, never tell me put where. Okay, you must tell me put where the thing. Yeah, same goes for fractional knitting column. Okay, I didn't give you because you didn't tell me it needs to be at the top of the round bottom flask. Okay, so basically all these you are supposed to suggest modification, right? Okay, so you must be specific, okay, where to put the apparatus. The question asked this way, cannot just say, oh, add one more fascinating column, then without telling me, where you put it. Okay. Other possible ones are replace the cold water in beaker with ice, replace Bunsen burner with electrical heater or water bath, so prevent direct heating lah. Okay, because down here, if you notice, the problem is direct flame lah. Right. Okay, so common mistake here, and why I rejected some of your answers okay, wait, wow, some of y'all can even write tell me what condensation column, don't even know what is that, or what Liebig pipe. Some of y'all you spell your apparatus all over the place. Okay, I don't know where you all get all these new ones. But most of the mistakes comes from not being able to tell me where you put it, or you just simply say condenser, which already the cold water already provide that ability to condense the vapor already. Okay, can. Okay, any questions you can post to me on Teams okay. Okay, so let's look at question 3 okay, in section B. Okay, so explain why the start line is drawn using pencil. So the focus here is on pencil. Some of y'all go and talk about pen, so I reject lor. Okay, you cannot use counter argument. This kind is what we call counter argument. I ask you one thing, you can explain about the other thing. So it's like two guy A and B okay, I say this fella handsome then I start explaining about this guy instead. Okay, you should tell me about A, right, when I ask you why A is handsome. Because what, got good eyes the hair very nice, all this instead you explain about B to me. Because the eyes is white, okay, not tall enough. No, it doesn't make sense, right? You are comparing between two things. You don't use counter argument okay, go straight, okay, focus on the pencil. Right, so what's so good about the pencil is that the graphite or the carbon is insoluble in the alcohol or the solvent, so will not travel up. Okay, this one, as long as you focus on the pencil, tell me it's insoluble in alcohol actually I give you the marks already okay. So long as you don't use counter argument some of y'all use counter argument, that's why I reject your answers over here okay. You must go straight into explaining how come the pencil is good. Those sort of things okay. Okay, then suggest the color of the ink that was used. Okay, so I think this one most of y'all know is green blue plus yellow okay, some art here this one I think was 100%. I'm not gonna explain much about this. Pretty much everyone know is green, I think. Seems like 100%. Yeah, explain this one very clear to you okay, very good. Okay, then the next thing okay, chromatogram X or Y is obtained using the descending method. Okay, descending method means this one okay. You are told the descending method is this solvent flow down water, as in diagram 1. Okay, so solvent flow down. This one you'll get the solvent to flow against gravity. So as a result, right, the chromatogram you can see lah, okay, it has a longer solvent front. Okay, so because of the pull of the gravity, solvent travel longer. Okay, so which chromatogram, X or Y, okay, so definitely the one in X. Some of them not consistent. You all will put Y, then tell me the correct reason, further solvent front. So like your answer self contradict one. So this kind I cannot give you a mark also. Okay, travel further distance, or you can say the solvent front is longer in chromatogram X. Okay, this one some of y'all not consistent. Yeah, and some of y'all is cannot identify is actually using the solvent front to answer this question. Yeah. Okay. Right, okay, next thing. The RF value. Okay, not much issue except this time around I think I was lenient. You actually need to put this to 3SF. Some of you never put this to 3SF. Okay, never put, just give me 2SF. Yeah, some of you give him percentage even. Don't need percentage, Yeah, so make sure around the 3SF. Some of you 4SF even. Yeah. So just take note lah this time round, alright? Okay. Then draw on the diagram I to show the position of the blue dye in chromatogram Y. Okay, diagram 3. Okay, so you know the R value is either 2.508. So you multiply by 6, the solvent front. This one you should get 1.88 cm around there. Okay, and it should be somewhere here, the middle of the dot should be here. Alright, okay, around 1.88 cm so in between the near to 1.9 basically. Yeah. Okay, then which method is better to be used in separating the different dyes in the ink? Explain your answer. Okay, so descending method okay, because why? Dyes will not overlap because they are far enough also, right, as a result of the longer solvent front. Yeah, some of y'all explain. Very funny, give me radial chromatography out of nowhere. Don't know why you give me radial chromatography. Totally no link one. Some say ascending, no lah. Ascending actually solvent front shorter, right? Cannot because shorter solvent front means the solvent actually travels a shorter distance right? Okay, then explain why the start line should be above the alcohol level. So this one what happens is you don't want the, okay, let's say this is the alcohol level, you want the start line here so that it will not dissolve. Yeah, okay, will not dissolve in the solvent before being carried up. Okay, some of y'all say very funny things that doesn't answer. smooth separation, all these not accepted lah, doesn't answer to the question how to separate when you already dissolve in the solvent. Some of you all say the alcohol dissolve and move upwards. So for these questions, some of you all say what dissolve, alcohol dissolve upwards and all that. No lah. This one is about what happens when you put it, inside the start line. Let's say the start line, you put it inside here. What happened? You will already dissolve inside, you see, before even traveling up. Yeah. Okay, so the key thing is to prevent sample from dissolving in the solvent. Okay, let's move to section C. Alright, okay, you can pause the video and copy this one recorded, not stopping to let you copy. Okay, let's take a look at this your ammonia gas. Okay, something regarding ammonia gas is a important starting material. So these are the different gas collection. Okay, so we go one by one. This one is what? Downward delivery, right? Okay, then method 2 is upward delivery. Okay, and then method 3 is downward displacement. Okay, so they are suitable for different types of gases. Okay, this is for those that is more dense. I think some of you are confused. Give me examples of less dense one. And then also those that are insoluble in water. This one is the less dense one. Then insoluble in water. Okay, so some of you I think not aware of how to explain. This question is play around with density as well as solubility one. Okay, so this one must be insoluble in water. Yeah, this one the key thing about this one is must be insoluble in water. Okay, so ammonia itself we know it's actually NH3. So calculate the MR is actually 17, which is less than 28. Okay, so less dense. Okay, so this one is you look for one that's less dense and then furthermore it's also soluble in water okay, plus soluble in water okay. So we can only use sorry, write wrongly. It's soluble in water. I write insoluble, goodness. Okay, so it should be method 2. Okay, method 1 not suitable because of the fact that ammonia gas is less dense. If you use this, the ammonia gas will float out. Yeah, cannot say lighter. Lighter is for mass. If you say lighter, then I will reject Okay, cannot. That answer doesn't work. Okay, yeah, lighter is for mass, not for density. Got people use lighter. Okay, some of you all got it wrong Then method, some of you all say denser, right? Which cannot Okay, then another thing, method 3 not suitable because it's very super soluble in water. Okay, so all this actually you can find inside your summary notes during the revision. Don't know whether you're going to look at it all this ammonia gas down here big for you to see, right? Okay, can. Okay, so you must actually refer lah to method 1, 2, 3 rather than tell me the name actually. Okay, next thing is give examples of gas that can be collected lah using method 1, downward delivery. Okay, so method 1 is downward delivery. So get those fellas that are more dense and then soluble lah. Okay, not accepted one is things like some of you put argon lah, helium over here for method 1, cannot lah. Let me see some of your answers. Okay, so this one by more dense means the MR must be more than 28 one lah, right? Okay, then this one is all the less dense one. MR less than 28 lah, right? Okay, some of you all put carbon dioxide down here, cannot. Carbon dioxide MR is actually 44, so this one cannot. Okay, then method 3, those insoluble ones, yeah. Other possible is carbon monoxide lah, also can. Okay, let me see sulfur dioxide can. Okay, some of your opposite I think. Looking through some of your answers now. Okay, can okay, then next one is a piece of apparatus to collect and measure gas so gas strange lah. Some of y'all, wow, give me very funny one, method 2 lah, all these kind of things This was actually cannot say strange if you just say strange I reject must be gas strange. I'll just say strange. Aiyo, measuring cylinder. Wow, actually got people tell me measuring cylinder can measure gas. You know lah. Alright, measuring cylinder is to measure volume of solution. So it's to measure volume of solution. Okay, right, and finally to the last part of this section C question. Okay, this one I think first one majority okay, 450 degrees Celsius, 250 atm. So just read off this way lor. Make sure you put as 27%. With units of course. Some of you put 27 no units, I reject. Okay, 0 marks for this one. Okay, must put percent. Okay, so remember to put your units. Alright, plus minus some 26 I also still give it to you actually. Yeah, okay. Alright, okay, I think I allow plus minus 1 okay, for this one. Give you a bit of allowance. Okay, next one. Okay, you are told that at a fixed pressure, okay, increase in temperature leads to an increase in percentage. Then very important thing, some of y'all use evidence means what? Code data. Probably half of y'all didn't code data Yeah lor, so many don't code data. Let me see. Wow, a lot At least 3 never put code data. Yeah, a lot didn't code At least about half the class didn't code Got explain must code data, use evidence Look out for this kind of question descriptors. Okay, must really read your question carefully. So I select the 250 ATM one from 400, okay, around 39 or 38 roughly okay, to 600, which is 7%. Okay, decreases from 39% to 7%. The temperature increase from 400 to 600 degrees Celsius. Okay, then next thing is for a temperature of 450 degrees Celsius. Okay, next one is what? Fixed temperature, increase in pressure, increase in percentage U. Okay, so agree, because if we fix it at 450, then we increase up to 550 for the pressure. It's around 48%, the blue color one. So temperature is fixed. When I increase pressure, then percentage U increase. Okay, then the other one, if I fix the pressure, I increase the temperature, the U actually drops. Yeah, so must code the data okay, you say pressure increase from 250 to 550, percentage U increase from 227 to 48. Okay, I mean you can code any set of data as long as it shows the trend. Okay, I think main thing is probably half the class didn't code data. Okay, so do take note of this. Okay, so when question tells you very clearly use evidence, please code data. Okay, I think you're not used to coding data. Okay, so now I'm going to go through the MCQ. Okay, for commonly wrong one, like for example question 10, 5 of you all got it wrong. Question 6, 4 got it wrong. Question 2, 3 got it. So I'm going to go through 2, 6, 10. Those with 1 or 2 of you all getting it wrong, or even like question 3 or 4, everybody gets it correct, I'm not going to go through it. Okay, so 2, 6, 10 are the ones that I'm going to focus on. Right, 2, 6, 10. Question 2 first. Okay, so stearic acid, okay, is actually solid at room temperature. Okay, room temperature means what? Means it's 25 degrees Celsius. Okay, which is around here. So this part is actually solid. This part, since it's a cooling curve, solid plus liquid. And then finally the orange part, this is liquid. Okay, so correct answer is C. Let's see why the rest is wrong. So at time T1 to T2, heat is absorbed from the surrounding. No, should be released to the surrounding. So A is wrong. Okay, at time T2, all stearic acid exists as solid. No, should be as solid and liquid. Then correct, right? Okay, so also wrong. Okay, then at time T2 to T3, all stearic acid exists as solid. No. Okay, solid and liquid Okay, so T2 to T3, some crystals, yes, that means some solid is formed. Right, question 2, then question 6 and 10. Okay, sorry, question 6 and 10. Okay, so sodium chloride, okay, this one very tricky, has a boiling point of 1465, but this is a solution. Okay, correct answer is B. Why? So the thing about it's a solution, means got water plus sodium chloride, right? Which one is the solvent? Solvent is this one. So even though it's concentrated, majority should be the solvent. Okay, yes, okay, majority will still be the solvent rather than the solute. Yeah, alright, even though it's concentrated. Right, so in this case, this one is the impurity okay, the main thing is the water, so it will raise, remember impurity will raise the boiling point, right? Okay, and drop the melting point, so that's why it's B. So focus more on the water rather than sodium chloride. Okay, question 10, next one. Okay, I got a lot giving. Okay, C. This one is tricky one. You want to measure 20.0 centimeter cube. Okay, So best is definitely Burette lah. Okay, follow by the pipette. Measuring cylinder is only to the nearest 0.5 centimeter cube. So not so accurate. So 1 and 3. Okay. This one I actually get the most people wrong. Got people put B. Got people put what else ah? Wow, a lot put B oh. This one. Wait, let me see. A lot of people actually put B for this one. Got people put D. Let me see. A lot of wrong answer. B a lot. I get a lot of B's for this one. Yeah, a lot of B's. This one. Got 4 or 5 put B. Yeah, okay. Can. Alright, so that's it for this video. Right. Okay, have a great March holiday.